Good afternoon, everyone. Today will be our fourth lecture on subject ordinary differential equation, CSB 1213, lecture 4. Today's our class content will be block 3, higher order linear differential equation, unit 9, unit 10, unit 11, and unit 12. We'll be discussing in brief so that we could complete the unit. Coming to our unit 9, complementary function, which is used as short form CF, and particular integral as PI. So a linear differential equation of order n, which is a, this is the equation of the linear differential equation of order n will look like. See, a suffix n d to the power n y by dx to the power n plus dot 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 a suffix 1 2, like that it will go on, which is equal to x capital within parenthesis small x. General solution will be CF plus PI. Complementary function, which is a CF, solve the homogeneous equation n d to the power n plus dot 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 a plus 0 suffix 0 equal to 0. Replace d dx with d. Okay, this one. So form the auxiliary equation AE. Auxiliary equation is known as AE. So root of auxiliary equation. There are three cases. Case 1, distinct real roots, which is y equal to c suffix 1 e to the power m suffix 1 x plus c suffix 2 e to the power m2 x. Case 2, repeated roots. When it's repeated root, c1 y equal to c1 plus c2 x e to the power mx is the common. So case 3, complex root. Alpha plus minus beta I. So y equal to a to the power ax c1 cos beta x plus c2 sin beta x. This is the equation of a complex root. So particular integral, which is pi, depends on right hand side, r s h. Right hand side, that is in the equation, this equation, this right hand side, capital X, so, within parenthesis small x. So general method, pi equal to 1 by f d x small x. Common case for pi is e to the power ax. Use 1 by fa e to the power ax. Sin ax, cos ax, use substitution d square equal to minus a square. So polynomial, use inverse operation, operator expansion. Moving to our unit 10. So Cauchy-Legendre equation and Legendre equations. Cauchy homogeneous equation form. How does it form? X to the power n dn y by dx to the power n plus till a suffix 0 y equal to 0. Method of solution. How to find the solution for this method? Substitution method. That is x equal to e to the power z tends to dx equal to 1 by x dz. This is how reduce to constant coefficient equation. Okay. Alternative method is assume solution. Leads to indicial equation, which is y equal to x to the power m. This is how the assume solution will be taken care of. So next, Legendre linear equation. Standard form 1 minus x to the power 2 whole bracket d square y by dx square minus 2x dy dx plus n plus 1 by n plus 1 whole y equal to 0. Key features. What are the key features of legendary linear equations? Appears in physics, spherical problems, and solution called legendary polynomial. Okay, moving to our unit 11, homogeneous linear differential equation. So what is the definition of homogeneous linear differential equation? It is a type of equation where the dependent variable and its derivative appear linearly to the first power, not multiplied together. Okay, and all terms involving or its derivative are on one side, summing to 0. So how does the equation look? So these are the equation: a suffix n x d to the power n y by dxn plus till a0 x y, okay, equal to 0. It's supposed summing to 0. It's supposed to be summing to 0. Okay. Properties: no right hand side term. RHS means right hand side term. Solution form a vector space. Superposition principle applies. The general solution is linear combination. Y equal to C1 Y1 plus C2 Y2 and Cn Yn till Cn Yn. This is linear combination. General solution will be linear combination. Next, moving linear independence, it's a fundamental concept in linear algebra, where a set of vectors is independent if no vector in the set can be expressed as a linear combination of the others. Okay, use Wronskian W, which is measured as W, y1 dash y2 dash dot not equal to 0. If it is not equal to 0, it is independent. It is called to be independent solution. Key concept: number of independent solution equal to order of equation. Next, moving to our simultaneous linear differential equation. The system of equations will be in simultaneous. How does this equation look? Dx dt equal to ax plus by. Okay, dy dt will be equal to cx plus dy. Okay, here the constant is ab, here is cd. Okay, elimination method: eliminate one variable. It's always eliminate in simultaneous linear differential equation. It's always eliminate one variable, reduce to a single higher order equation. Okay, operator method: use differential operator d and solve like algebraic equation. Matrix method: advanced, write in matrix form. So d capital X by dt equal to ax. Solve using eigenvalues. This is when it is a matrix method, it is used eigenvalues to solve the problem. So moving to our example for solve questions for unit 10. Let's see example here. Go through it. If you have any doubt, you can cross question. See here, solve x plus 1 plus x to the whole square, d square by y, dx square plus 1 plus x, dy dx plus y equal to sine 2 log 1 plus x. Okay, this is the question. So what will be the solution? What we have learned in unit 10, CF and PI. No? So we have these equations, then we will substitute, you see, we have substituted it in the second line, substitute the value, and putting these values in the given differential equation, we get d minus 1 y plus dy plus y equal to sine 2z, or d square minus d plus 1 d plus 1 y equal to sine 2z. This is how the equation will look AE, auxiliary equation. This is AE, means auxiliary equation is m square plus 1 equal to 0. Until and unless you solve it, you won't understand. So for explanation, I have taken one example here. Solve questions to make you go through it. Equal to m equal to plus minus I. CF a cos z plus b sin z. You know? Pi means 1 by, what is the cos? If it is cos z, then what will be the value? 1 by sine. And we have converted this cos into sine. Then we'll substitute the value again here. Minus 4, the square means 4. And what is the answer? Minus 1 by 3 sine 2z. Now complete solution is y equal to CF plus PR. So CF, what is the CF value? This one, and PR value is this one. So we'll add this one. Y equal to this plus this minus this, and this is our final value to find CF and PR. Next questions for this is from unit 11. This is the given example question. Put x equal to Ez. This is substitution again, putting the auxiliary equation, substituting in the given equation we get this one. You see, you can solve it in this way. Then auxiliary equation is m cube minus 2 is m square plus m minus 2 equal to 0. That is m minus 2 m square plus 1 equal to 0. Then this is CF. We get the CF value here and PI value, this one. Then therefore, this is the final solution for this question. Next, solve question from unit 2. The question of motion of the particles are given by, see, and in the same way we have substituted the value on multiplying, and we are multiplying by W and 2 by D, we get this one. And on adding 3 and 4, now we are adding equation 3 and equation 4. So we get equation 5. Now we have to solve 5 to get the value of y. Now auxiliary equation will be getting, and on putting the value of dy in 2. Now we'll put this value in equation 2. Okay. Then equation 7 will get on squaring 6 and 7 and adding. First we'll square, then add. Then what will be the answer? This. This is the equation of circle. Okay. Thank you. If you have any queries, you solve as much as problem in this subject, because it's very much important to practice. And if you have any query or doubt, you can email me in this email ID given here anytime. You can reach out. Thank you for joining the class. I didn't keep long slide because it will be very difficult to understand if we keep long in the content. So next class will be going with 13, 14, unit 15, 16. Thank you. Next class will start at 2:30. 2:30.